Hello everyone. Today I'll try to explain you the relation between time zones of Earth and rotational movement of Earth around its axis. We take time for granted, but today I'll try to explain you how timekeeping is being done, and after today I believe that you will not take time for granted and you will not take wristwatches and clocks on walls for granted because they had to travel a long evolutionary history. Today, we'll try to understand and acknowledge the role of different factors and different people in determining the concept of timekeeping and precise movement of Earth's rotation around its axis. To understand what is timekeeping, we need to know few other important concepts. First of all, we need to know what is meant by rotation and revolution and how rotational movement of Earth around its axis and revolutionary movement around Sun are relatable. The concept of latitudes and longitudes is not new, but in today's lecture we'll try to understand how longitudinal lines are important when it comes to determining timekeeping. Evolution of timekeeping is basically acknowledging those people and civilizations which played their role to determine timekeeping. How many time zones are there? How they are different from each other? How they are adjusted? Adjustment is quite complex phenomenon, let me tell you. How they are adjusted and on the basis of what there we have 24 time zones. We'll try to understand in that slide. By the end of today's lecture, I hope that you will be able to find time differences between two or more places. And in the end, I have given you few exercises to understand the concept of timekeeping better. Earth is rotating around its axis and revolving around Sun simultaneously. Both movements are in anti-clockwise direction as are shown in this diagram. Earth is rotating around its axis and revolving around Sun in anti-clockwise direction. Earth is third planet in solar system and one of the tiniest planets of solar family. These two facts make our Earth to spin around its axis very fastly. It is spinning around its axis with the speed of 1666 km per hour. You can easily relate this speed by comparing it with the driving speed of your car. When it comes to keep record of minutes, hours and days, then Earth's rotatory movement around its axis is helpful. But when it comes to keep record of years, decades and centuries, then its revolutionary movement around Sun is helpful. Latitudes and longitudes are shown in this diagram. Both are imaginary lines. Latitudes are horizontal lines and are drawn along x-axis. They are important when it comes to understand uneven distribution of heat around the globe, and that is the topic of a separate lecture. Longitudinal lines are important when it comes to understand the concept of timekeeping. Earth is a sphere, and all of us know that according to principles of geometry, every spherical and circular object has 360 degrees. That makes our Earth to have 360 longitudinal degrees. And as I have told you that Earth is spinning around its axis with the speed of 1666 km per hour. And with this speed, it takes 4 minutes for one longitudinal degree to pass in front of Sun. That makes all 360 degrees of longitudes to pass in front of Sun in the duration of 24 hours, and that makes one day on planet. Here I have selected few images to show you the evolution of timekeeping devices. This first picture is of a sundial that has a half circle simply carved on a plain rock and has a stick in center of it. It works on the principle of sun's movement in the sky. The shadow of the stick where it passes the half circle actually tells us what time of the day at the time of observation. Our modern clocks and wristwatches are modified forms of sundials. This second picture is of an hourglass that simply divides 24 hours duration in day and night. This third picture is of utmost importance because this is of Royal Observatory of London. Its foundational stone was laid in 1675 by King Charles II. With the passage of time, it was improved and precision was added. Royal Observatory of London is important with respect to many aspects. As I have told you that all the longitudinal lines are imaginary lines, but this 0-degree prime meridian that passes from Royal Observatory of London is actually constructed on planet. All the other time zones of Earth are basically divided with their respective geographical distances from Royal Observatory of London. This fourth picture is of an atomic clock that measures time up to nanoseconds. To measure time up to nanoseconds is important when we have to launch satellites, submarines, or when we have to keep record of time in nuclear and in nuclear fusion and fission reactions. So the evolution of timekeeping devices from simple rock to an atomic clock was not very easy. It took a lot of hard work and patience for scientists to devise such timekeeping devices that can measure time up to nanoseconds. Most of the facts listed in this slide we have discussed earlier. But let's just have a quick review of few important facts to solve numerical examples. 0-degree longitude is called prime meridian, and that is the starting point to calculate the time difference for other time zones. And exactly opposite to 0-degree prime meridian, we have international dateline that is situated on 180 degrees of longitude. And between these two important lines, we have eastern and western hemispheres, and that possess 180 degrees for eastern half and 180 degrees for western half of the world. And we have discussed this fact also, that it takes 4 minutes for 1 degree longitude to pass in front of sun with the spinning speed of Earth, as I have told you, and that makes 15 degrees longitudinal lines to pass in front of sun, and they take 1 hour or 60 minutes to pass in front of sun. That makes our Earth to have 24 time zones. 12 time zones for Eastern Hemisphere and 12 time zones for Western Hemisphere. To calculate the time difference between two locations, you need to have at least time of one location and longitudinal differences between these two locations. Let's just try to understand all these facts with the help of example. Let's try to relate all these facts by solving an example. I have given you the longitudinal degrees of 3 cities, Lahore, Dhaka, and Istanbul. Lahore is situated on 74 degrees eastern longitude. Dhaka is situated on 90 degrees eastern longitude, and Istanbul is situated on 28 degrees eastern longitude. All three cities are situated in eastern hemisphere. I'll help you to calculate the time difference between Lahore and Dhaka, and if you understand it well, then you have to solve the time difference between Lahore and Istanbul on your own. Let's try to solve the example. I have divided the time difference calculation process in 3 steps. In first step, you have to calculate the degree difference between two cities of your concern. Dhaka is situated on 90 degrees eastern longitude, and Lahore is situated on 74 degrees eastern longitude. That makes the time difference between two cities of 16 degrees. In second step, you have to multiply this degree difference by 4 from where this 4 came. It takes 4 minutes for 1 degree longitude to pass in front of sun. If you multiply these 4 minutes by degree difference, you will get the time difference of two cities of your concern in minutes. In the third step, you have to convert these minutes in hours and remaining minutes. That will give you the exact time difference between two cities of your concern in hours. And between Lahore and Dhaka, the time difference is of 64 minutes. That means the time difference between these two cities is of 1 hour and 4 minutes. That means if it's 12 noon in Lahore, at that time it will be 1:04 p.m. in Dhaka. As Dhaka is situated in east of Lahore, so definitely it will be ahead of time in this calculation process. I want you to pause here the video, and you have to calculate the time difference between Lahore and Istanbul on your own. And Istanbul and Dhaka, you have to pause here the video and try to solve the time difference between these two cities. I hope you have solved numerical examples. I hope you have calculated the time difference between Lahore and Istanbul, Istanbul and Dhaka. You can comment your answer in comment section below. Here we have the map of time zones. In this map, you can see black lines. This first line is of 0-degree prime meridian, and this second line, that is 180 degrees international date line. This first line is not very well adjusted. It is passing from Atlantic Ocean and from many African and European countries. 0-degree prime meridian is basically the starting point for all other time zones to adjust their time as per their degree longitudinal distance from 0-degree prime meridian. Here we have international dateline that is situated on 180 degrees of 180 degrees longitude. As you can see that this is a well adjusted line. This adjustment is observed to avoid any inconvenience. Like if a country has more than one date, then it can cause many inconveniences. To avoid the inconveniences in international flights, in delegation movements, and to manage political, administrative, and all other affairs, we have this time adjustment. So when it comes to adjustment of time zones, then countries have not adjusted their time zones as per their longitudinal degree location, but countries have adjusted their time zones politically, not geographically. That means the countries have adjusted their times with respect to the time of their capital. There are countries that are larger in areas like Russia, Canada, and America. These countries have more than one time zones, but still their time zones are adjusted. Let's take an example from this first time zone, that is uh, -1 hour, showing that is basically -1 hour time difference is basically its time difference from 0 degree prime meridian. Here we have a second time zone, here we have third time zone, and this this color is basically showing that all the respective countries that have this same shade, they are situated in this time zone, no matter if they are situated in this time zone of 0 degree prime meridian, but um, as per their convenience, they have adjusted according to their nearby time zone. And you easily can relate from this map that that the respective color of their administrative division is the time of their or time of their area, that is basically beyond their uh, geographical location. Here I have given you a few other examples to test your time calculating skills. Uh, you can solve these examples with the help of your instincts, with the help of skills you learned from this video. You can comment their answers in comment section. Read these statements carefully and try solving them, as I believe that time calculating skill is now part of your cognitive domain. Thank you. Uh, you are welcome to suggest any suggestion, and if you have any question, then you people are very welcome. Thank you.